Okay, here we go. We've got a question here about a car decelerating uniformly to rest, and we're being asked to compare the distances in two different stages and going from v to v over 2 and then from v over 2 to 0. Okay, so I hope you've had a chance to try the question. Let's go for it. Now, in this question, we're talking about acceleration, velocities, and distances. So I hope what comes to mind is SUVAT. SUVAT is usually the kind of thing that we would apply when we're doing these kind of questions. Now, there are 4, and according to some teachers, 5 SUVAT equations, so it's sometimes not clear which one to use. Let's have a look here. We've got acceleration, we've got velocities, we've got initial and final velocities, and we've got distances. So the one that comes to mind for me is this one here, the v squared equals u squared plus 2as, because we're linking velocities, distances, and accelerations. This is where I don't really like this question because they use some confusing numbers, and confusing letters, I should say. We're starting with an initial velocity v. Now, if you notice here, initial velocity is usually u. So I'm going to put this up just to say what I've done here. We're going to call this final velocity, that's v over 2. Initial velocity is v, we're squaring both of those, and we're saying plus 2ad. D here is going to be our distance, which is covered. So what we're going to do is we're going to rearrange that for d. We're going to notice that we've got v squared over 4 equals v squared plus 2ad. And then if we rearrange that, we're going to end up with something quite ugly, okay, which is that the distance is minus 1 over 2a times 3 over 4 v squared. Okay, now why are we doing that? Well, what we're going to do is we're going to compare that distance with the distance traveled in the second leg of this journey, if you like, which is when we go from v over 2 to 0. In other words, from v over 2 to rest. We're going to do exactly the same process, except this time our final speed is 0, our initial speed is v over 2, or initial velocity I should say, and we've got the same acceleration a. Okay, now I've called the unknown distance x, and what we're going to try and do is find out what that x is. Okay, we're going to square again. We've got v squared over 4. Ooh, and it doesn't look very nice. We're rearranging for x. We're going to have minus 1 over 2a, v over 2 squared, v squared over 4. Okay, now, if you compare this term here, which I'm kind of circling, hopefully you can see that with the cursor, with this one here, it's exactly the same, except for this 3. So if you imagine I take this term and I divide it by 3, I'm going to get d over 3, which is why the answer here is B.